Hello everyone. In this particular video, we will be discussing about a very important and interesting topic for statistics, that is z-score. Before starting with z-score, let us first see normal and standard normal distribution. As I can see, the first distribution represents a normal distribution, whereas the second distribution represents the standard normal distribution. We already know that a normal distribution is represented by a bell-shaped curve, and it can be described using two parameters, that is mean and standard deviation. The normal distribution is centered about the mean. This point lies one standard deviation above the mean, and this point lies one standard deviation below the mean. Similarly, I can have a point which lies two standard deviation above the mean, another point which lies two standard deviation below the mean. On the other hand, the standard normal distribution is similar to a normal distribution. The only difference is that the standard normal distribution has mean equal to 0, that is, it is centered about origin, and standard deviation is equal to 1. So this is the point which lie one standard deviation above the mean, and this point lie one standard deviation below the mean, and it is equal to -1. Now, under the topic of normal distribution, we studied about empirical rule. The empirical rule states that 68% of the data points lie within one standard deviation of the mean. 95% of the data points lie within two standard deviation of the mean, whereas 99.7% of the data points lies within 3 standard deviation of the mean. Let us say, if I need to calculate how many data points lie below this point, say this point is 1.5 standard deviation below the mean. Using the empirical rule, I cannot find this. So to get this value, I take help of standard normal distribution and z-score. So if I want to convert a normal distribution into a standard normal distribution, what I can do is I can subtract the value of mean from all the data points. That is, if from every data point I subtract mean, then I can say that my normal distribution will get located at the origin. If I subtract mean from this point will become equal to 0. This will become equal to minus sigma. This will become equal to plus sigma. Now, if I compare, I got mean equal to 0. To make these values as -1 and 1, I can divide this value by sigma. So using this formula, I can convert a normal distribution into a standard normal distribution. I call this formula itself as z-score. So this is the value of standard normal distribution, which is also known as a standard score or z-score. So moving ahead, as we saw that z-score is a parameter that tells us how far a data point lies from the mean in terms of standard deviation. The formula of z-score is given as z equals to data point minus mean divided by sigma, that is the standard deviation. Now, let us consider an example. Suppose a person takes an exam and he scores 500 in that. The mean score is given as 390 and the standard deviation is given as 45. I need to find out how well the student performed in that exam. So I'm given that the score is equal to 500, mean is equal to 390, and standard deviation is equal to 45. So firstly, to find how well the person performed compared to other students, I need to find the z-score. As I know that z-score is given using the formula z equals to x minus mu divided by sigma. In this case, it will become equal to 500 minus 390 divided by 40, which is equal to 110 divided by 45, and I'll get my z-score as 2.44. So this is the value of z-score that I got. So as per the definition of z-score, I can say that this point lie above 2.44 standard deviation of the mean, that is, it lie above mu plus 2.44 times the standard deviation. Now let us consider a standard normal distribution for this example. So a standard normal distribution is centered about origin. This point will be one standard deviation above the mean and it will be equal to 1. This will be equal to 2 and this will be 3 standard deviation above the mean and will be equal to 3. So my z-score lie somewhat here. So this point will be 2.44. Now in order to find how well the student scored as compared to other students, I need to calculate this area. So this entire area will give us the percentage of data point that fall below 2.44 z-score. So to get this area, we take the help of z-table. Now let us see what a z-table looks like. As we calculated, the z-score was equal to 2.44. So to get the value, I need to map the first 2 digits of the z-score on the y-axis and the third digit on the x-axis. If I look this z-table, 2.4 lies over here, and if I look the x-axis for the last digit, that is equal to 4, the value 0.04 lies over here. So the intersection of these 2 points will give me the p-value. So the intersection of these 2 points will become equal to 0.9926. The value will become equal to 0.99266. If I multiply this by 100, I get 99.27. So in this question, I can say that 99.7% of the data points lie below 2.44, or I can say that 99% of students scored less than 500. I hope you understood the concept and calculation of z-score. If you liked the video, don't forget to hit the like button and subscribe the channel. Thank you.